name is Chris Hayes. This is Joe Coverston. This is Giancarlo Lombardi. Our project is on mechanisms, in particular the analysis of a slider crank and synthesis of a 4-bar. So before we start, a short introduction of what a mechanism is. A mechanism is a device consisting of rigid links connected by joints. Some early examples of mechanisms from thousands of years ago were devices used to trap animals for food. As the years progressed, mechanisms became more and more complicated. Some other examples are weapons used for war, like the trebuchet and ballistas. And one of the most complicated mechanisms is the clock, which was invented in 1659. Okay, so our first thing we did is analysis of a slider crank. Basically, a slider crank is a variation on a 4-bar, which consists of a crank input that converts input or rotational motion into linear motion via a slider. Here's our given information. We're tasked with finding theta 3 and R1 given a full rotation of the crank, which is theta 2. These are our results of R1 and theta 3 versus theta 2 given in 60-degree increments. Our first graph result shows the link 1 length versus the input angular position. Our next graph is the angular position of the coupler versus the input angular position. And now I'm going to turn it over to Giancarlo for the analysis of point S.
So we determined that a QS value would be given as 8.3 inches with a theta 5 value of 15 degrees. So given these inputs, point S was established a trajectory provided here. So moving on to the velocity analysis, knowing that link 2 rotated with 3 radians per second, with an angular velocity of 3 radians per second, these were the velocity of link 1 and the angular velocity of link 3. And the velocity profile for link 1 is provided here. And the angular velocity of the coupler link is provided here as well. The acceleration analysis followed the same procedure, where we knew the angular acceleration of link 2, the input link, which had 0 radians per second squared. Given 60 degree increments of the input link, the linear acceleration of link 1 and the angular acceleration of the coupler link are provided here. The full acceleration profile of link 1 is provided here. And then the angular acceleration of the coupler link is provided here as well. Some applications of a slider crank mechanism include an internal combustion engine and an air pump. Here we have created an air pump model where the full rotation of the input crank is shown to move the piston within the cylinder. Okay, so now I'll pass it on to my colleague Joe, who will explain 4-bar mechanical synthesis.
Great. Here we have the basic 4-bar synthesis. And here are our given calculated points. So A1, B1, A2, B2. So these are the positions that we have to have the 4-bar travel through. Right. Next up, here are the equations that we use to synthesize our 4-bar. So once we have these plugged in, we end up with the initial pole position of A0, B0, and using the distance formula, we calculated these 4 lengths of our 4 bars. So R1, R2, R3, and R4. All right, here's the verification we used, SolidWorks, to verify that our synthesized 4-bar did indeed go through all 3 pole positions. here is a realistic application of our 4-bar system. We have chosen a clamp, and here we have it in its natural environment. And so here we have a video that we've made animating our 4-bar. So you can see as it moves through those pole positions here, it actually clamps down on whatever object is in its path. All right, thank you. That concludes Team 30's presentation.